Okay, so these are our next basic proof rules. There's 4 of them. The first 3 are really straightforward. The last one's a little bit complicated. So let's go through these first 3. So here's an example. You ate an apple and you ate a banana, right? You ate an apple and you ate a banana. Now, if someone were to tell you, based solely on that, the phrase, you ate an apple, right? Would you call them a liar? No. This is logically inferred from that. It's basically what we do every time we have a conjunction and we want to just talk about a piece of it. We simplify the conjunction to just talk about one part. So this rule is called simplification, or simp for short. So translated into logic, you ate an apple and you ate a banana. So if you know that you ate an apple and you ate a banana, then you know that you ate an apple. You could also write down you ate a banana. Right? If that was line 1, then this would be line 1, simp. This would also be line 1, simp. A couple of important things to talk about here. Right? This is simplification. Anytime you have a dot, you can break it apart. It's a one-line rule, so you can do it whenever you want. Anytime you have a dot, you can break it apart. Also important to note that just because we use it one time, right here on line 2, doesn't mean we can't go back to it or can't use it again. Lines don't get broken, they don't get used up. So don't make more rules, don't make proofs harder than they need to be. If I know that I ate a banana, or you ate a banana and you ate an apple and you ate a banana, then I know both those things and I can put them down separately. So what this rule allows us to do is to break apart conjunctions. That's simplification. So another rule allows us to put conjunctions together. So if I know that I ate an apple and I know that I ate a banana, would it be wrong to say I ate an apple and banana? Right? No, of course not. That would be a perfectly reasonable thing to assume. If I know this and I know that, then I can put them together. This rule is called conjunction, conj. We just call it conj. Not really sure if it's a fancy title, but we just call it conj. C-O-N-J. So see that simplify, or see that represented in logic, right? A, B. So any lines we have, we could say if I know that I ate an apple and I know that I ate a banana, then I know that I ate an apple and I ate a banana. Right? So I've just put those two together. If this was a proof, right, then this would just be line 1, line 2, conj. So basically what the rule conj says is take any line you want, right? So take line 1, write it down, write a dot, and write any other line you want, B. So conj allows us to put 2 lines together, allows us to glue 2 lines together with a dot. In this case, I decided to glue line 1 and line 2 together with a dot. Okay, that's conj. It allows us to make conjunctions. This rule is kind of confusing, but really, really useful, and that is the add rule. So if I know that I ate an apple, then I know that I ate an apple, or literally anything you want, or a frog, right? Because it doesn't matter if that's true or false. I know that this is true, right? So, right, with our truth tables, remember that? If I know this is true, then it really doesn't matter what f is. It doesn't matter if the value of frog, because regardless, this is going to be a true disjunction. You don't need to know that to do proofs, but it's just kind of an explanation. So this symbolized anything you have, right, any line you have, you can just rewrite it, wedge, make something up. That's the cool thing about add. So if this is line 1, this is line 1, add. You can literally make up whatever you want with the add rule, as long as there's a wedge. So I could say line 3, A wedge tilde G, right? 1, add. Where did that wedge tilde G come from? The answer is I made it up with my add rule. That's what addition allows me to do. It allows me to make up rules. This is very, very important. Right? And you'll notice that I can do this over and over again because there's no rule that stops me, right? If I can do it once, I can do it as many times as I want. I can add to the right side, right? I can add to the right side of A, or if I want, I could add to the left side. See right there? I made something up again. I made up 1/2, but I made it up on the left side. This is a trick that for some reason a lot of people have trouble with. You can add to the right or you can add to the left, and it doesn't matter which. Okay? So that's addition. Our final rule is called Constructor Dilemma. I didn't spell this out in English because it's one of those things where it's just kind of complicated. The notes do a really good job of explaining it. Really old Constructor Dilemma, which is pretty cool. But for the purpose of this, I just want to explain it as simply as possible. So the reason why Constructor Dilemma is a little tricky is because it requires 3 lines. Most of our lines are 1 line or 2 lines. This is a 3-line rule, or 1 and only 3-line rule. So what Constructor Dilemma requires is you need a disjunction and you need 2 conditionals. But not just any 2 conditionals and not just any disjunction. You need a disjunction where each disjunct, in this case A and B, are the left side of arrows. So if that happens, right, if you have this kind of pattern, that allows you to form a new disjunction out of the consequence of those arrows. Here's an easy way to remember it. I call this guy up here the daddy. The daddy disjunction. This down here is the baby disjunction. So this is the daddy disjunction, right? This is where the disjunction comes from. So A or B. A is the antecedent of this conditional. B is the antecedent of this conditional. And that allows me to form a new disjunction out of the consequence, out of the right sides of those conditionals. Now, it's really hard to see CD sometimes, to see CD, to see Constructor Dilemma, sometimes because there's 3 lines, and so it's a little bit tricky, but basically anytime you're stuck and you see 2 arrows and a wedge, check out CD and see if you can find it. So, quickly review, what would you do if I had, right, B, arrow R, and tilde F, arrow P, and I had the disjunction B, wedge, tilde F. What could you make out of that, right? If this was line 1, 2, and 3. Right? See that pattern? There's the daddy disjunction. And I know that because, look, B is the left side of that arrow, and tilde F is the left side of that arrow. So on line 4, I could write R, wedge, P. 1, 2, 3, C, D. I could also write P, wedge, R. I could write that however I wanted to. So that's Constructor Dilemma. Let's do some practice proofs to show kind of some more examples of this.